this Trig Table graphic organizer. Remember, if you're watching this on YouTube, smash the like button. I want to be like Cardi D and be like popular. Okay. When you have a right triangle, and the slope angle is 0 degrees, your delta y side will be 0. Your delta x side will be 4. Okay, now once again, there is a mathematical reason why that is. I'm not going to explain it today. You're just going to take my word for it. Which would make your slope? What would that make your slope? 4 over 0 or 0 over 4? Which would make your slope 0 over 4. You guys in Slovakia who are watching this is an amazing third period class I have. Of course, if you're watching in Slovakia, you probably don't know anything that I'm saying because you speak Slovakian and not English. But, we're just going to go with it. 0 or 4. Now, you will notice as I fill these out, I will always leave my slopes as fractions. I'll never simplify them. Okay, like over here we have 1 over 5. They simplified it to the decimal 0 over 2. I'm just going to leave my answers as slopes. I think it makes it easier. And by the way, some of the numbers are very easy, friendly numbers like 0 and 4. Some of them are not. So the next one, when you have a right triangle and the slope angle is 8 degrees, that would make your delta y side 26. And that would make your delta x side 185, which would make your slope 26 over 185. Okay? Moving down to the right triangle that had a slope angle of 18 degrees. When the slope angle of a right triangle is 18 degrees, that makes your delta y side 1 and your delta x side 3. Which would give you a slope of 1 over 3. Now, once again, remember, the numbers don't have to be 1 and 3. They just have to be two numbers that when you write the slope, it has to reduce to 1 over 3. For instance, instead of 1 and 3, what could I have? 2 and 6. Or 3 and 9. Or if I wanted to get crazy, I could do 100 and 300. Right? Right? What is 100 over 300 reduced to? 1/3, okay? When you have a right triangle and the slope angle is 22 degrees, that makes your delta y 2, your delta x 5, which means that your slope is going to be 2/5. When you have a right triangle where your slope angle is 45 degrees, that means both of your delta x and delta y's will be 1. So it would make the slope 1 over 1. Okay, once again, to hammer this point home, it doesn't have to be 1 and 1. It could be 8 and 8. It could be 12 and 12. As long as the numbers you have reduce to the fraction 1 over 1, it's fine for that particular right triangle with that particular 45-degree angle. When the slope angle is 55 degrees of a right triangle, your delta y is 10, your delta x is 7. And that gives you a slope of 10 over 7. When your slope triangle is 68 degrees of a right triangle, your delta y is 5, your delta x is 2. That makes your slope 5 over 2. Okay, and this is the very first one that something kind of wild happened. What do you guys notice about the 68-degree triangle when you compare it with the 22-degree triangle? Opposite. They are not opposites, they are... What's that big math word called when the fractions are like flipped of one another? What? They are reciprocals of one another. Okay, you will notice you'll have a few of these like this. And there is a mathematical reason why that is. One of these days when you grow up, you'll know it. Today's not that day. Okay, 70 degrees gives you, and this one's ugly. It gives you a delta y of 13.737. Let's see. Hold on. Make sure I got that right. Yep. 13.737. And it gives you a delta x of 5, which would make your slope 13.737 over 5. Okay, when the right triangle has a slope angle of 72 degrees, you get delta y of 3, delta x of 1, slope of 3 over 1. And if you notice, that's the reciprocal of 1 over 3, which is the 18-degree angle. Okay? Oh, check this out, you guys. I think I see something. When I have the reciprocals, like 1 over 3 of 3 over 1, like the 1 over 3 had the slope angle of 18, but the 3 over 1 had the slope angle of 72. What's 72 plus 18? 90. Whoa. When I had 5 over 2 and the slope angle was 68, and I had 2 over 5 and the slope angle was 22, ooh, what's 22 plus 68? 90. Anybody see what's going on? Anybody see a pattern developing with when I flip the slopes? Okay, you don't have to answer. It's okay.
Yeah.
Okay, thank you, Sheldon. That was Sheldon for those of you in Hungary watching this right now. Okay. Girls, he's single, by the way. Sheldon, you'll probably get like 87 billion IMs from girls in Hungary now. If you haven't had dinner and you live in Hungary, you know what country you should go to? Turkey. Yes. Evelina. Okay, when the slope angle is 79 degrees, that makes the delta y 5, the delta x 1, which makes your slope 5 over 1. And if you notice, that's the reciprocal of 1 over 5. 11 degrees plus 79 degrees is 90 degrees. Okay, when the slope angle is 83 degrees, excuse me, you get delta y of 25, you get delta x of 3, which makes your slope 25 over 3. When you have an 84-degree slope angle on a right triangle, that makes it the sides 10 and 1, which makes your slope 10 over 1. And the last one, when you have an 89-degree slope angle, this one's ugly, you get 5,729 for delta y, and you get 100 for delta x, which makes your slope 5,729 over 100. All right, congratulations, you guys. We have just completed the Trig Table graphic organizer. You have no idea how I got these numbers, but just take my word for it. There's a mathematical way. Ryan.
So the 80-degree angle, what is the number on top of the 3?
The which one?
Yeah.
This right here? 25 over 3 for the 83. Okay, sorry. I didn't draw that very legibly. I got in second grade in Mrs. Buss's class at May McCardle Elementary School, I got an F- in penmanship. I'm actually better than I used to be. So we've got that there. Okay, do we have all this filled out? Okay, you guys are going to have to not lose this paper. You're going to have to refer to it, okay, over and over and over again. Now, go to your notes packet, and there's like 3 or 4 pages that are titled question mark, question mark, question mark. Okay? Go to one of those pages that's titled question mark, question mark, question mark, and fill in this title, Finding the Missing Side of a Right Triangle Using the Trig Graphic Organizer. Okay? That's what we're going to change the title to on one of those pages. Find the missing side of a right triangle using the Trig Graphic Organizer. In other words, for those of you who are like text all the time, FTMSOARTUTTGO. You don't have to put that. That's text talk for those of you who are cool like me, who can text on their phone using one finger only. Okay, so like if somebody texts you this tonight, hey, how do you do the homework in Mr. Trutna's math class? Just text them back, FTMSOARTUTTGO. Find the missing side of a right triangle using the trig graphic organizer, okay? All right, I need a volunteer. Who's going to be my volunteer? Victoria? Okay, Victoria, this is all that I ask you to do, okay? I'm going to ask you to give me an angle measurement, and it has to be one of the angle measurements from the trig graphic organizer, okay? And then you're going to have to give me a variable and some whole number, any whole number you want, okay? Think you can handle that pressure? All right, so everybody, here we go. Example number 1. We are going to delve into this. This is the first ever time we're going to find a missing side of a right triangle using the trig graphic organizer. You guys will never ever forget this moment in the rest of your life. This is going to be like as momentous as your first kiss. Like you're never going to forget this. So when you turn 25 and you finally get your first kiss, you guys are going to remember this. Okay? Victoria, I need you to give me a slope angle, and it has to be from the graphic organizer. Which angle would you like? 84. Oh, thank you for picking a nice, easy one. Okay? By the way, like last class period, the guy picked 70 right off the back. So then it doesn't make it harder. It just makes it, okay. So we're going to make that slope angle 84 degrees. Okay, this side, Victoria, of the triangle, I want it to be a variable. What variable would you like to choose? No, I want it to be, are you asking me why?
No.
Oh, you want the variable to be y? Yeah. Okay, so we're going to use the variable y, and then this bottom side of the right triangle, Victoria, I need it to be a whole numbered length. Yeah. I said a whole number, Victoria. Yeah. Okay, just wanted to see. 12 is a whole number there. Okay, yeah, so we're going to make that 12. Okay, all right, so you guys, here's my problem. I need to figure out what's the value of y. All right, I'm going to give 5 extra credit points to somebody right now in class if they can answer this question correctly. You don't even know the question yet.
I know it.
Okay, and if you get it wrong, I'm taking 5,000 points off your grade, so it's not a freebie.
Okay.
All right, so show of hands. Who could intellectually explain, as to why I cannot use Pythagorean theorem to find the value of y in this particular problem? Ethan.
So in order to use Pythagorean theorem, we need at least 2 of the sides.
Couldn't have said it better myself. In order to use Pythagorean theorem, for those of you in Czechoslovakia, if you didn't hear Ethan, you have to know at least 2 of the sides. I only have one side. It's 12. So here is what I'm going to do. I am going to go to my Trig Table graphic organizer. I'm going to find the triangle that has the 84-degree angle in it, which you can see is the second to last triangle, and I am going to copy that triangle next to the triangle on the of the problem that I'm trying to find the value of y on. Okay? So I am going to take the triangle from my trig graphic organizer, and I am going to copy that triangle right next to this triangle, even filling in the numbers that I had there, which were 10 and 1, right? Which were 10 and 1. All right? Now, I do need to point this out when you do this. When you copy the triangle from the graphic organizer next to the given triangle, you have to orientate the triangle in the same manner. Does everybody know what I mean by orientate the triangle in the same manner? Okay, if you don't know, don't write this down, but this would not be how you would do it. If you drew the triangle from the trig graphic organizer like this, do you see how that red triangle is not oriented the same as the given triangle? Yes or no? Okay, you have to orient it the same. You really don't have to, but it'll just make your life so much easier. Okay, guys, yes or no, are these 2 triangles congruent? The answer is no. They are not congruent. Congruent would mean they're the same size, which would mean that this of the blue triangle, that bottom side would be 12. Okay, they're not congruent, but are they similar? Yes, these two triangles are similar to one another. How do I know that the two triangles are similar? Because they each have two angles that are equal to each other. Very good. So they are similar because of the angle rule. Okay? Now, when two triangles are similar, here's what you do to solve for a missing side. You write fractions, you cross multiply, and you solve for the missing piece. Okay? So I'll say that again. When triangles are similar, what you do is it means that the fractions comparing one triangle to the other triangle are the same. You cross multiply and you solve to find the missing piece. So let's go ahead and write our fractions. What matches up with 12 but in the other triangle? 1. So one of my fractions is 12 over 1. Okay? What matches up with y but in the other triangle? So another fraction is y over 10. Okay, now, when triangles are similar, it means that the fractions you write are equal to each other. And then you cross multiply to solve this problem out for y. Okay, so I'm going to cross multiply. I'm going to go 1 times y. What is that? That is y. I'm going to go 12 times 10. What is that? 120. The results of when you cross multiply are equal. Bada bing, bada boom, as they say in Brooklyn, I just found the answer. Y is equal to 120 in this problem. Okay? There we go. We just did our very first problem where we had to use the trig graphic organizer. You guys are never going to forget that. Like, this is like awesome. As a matter of fact, if you were a bunch of goats, you would probably all pass out from excitement right now. You know how goats pass out when they get excited? Yeah, okay. So remember I said that at the beginning of the class is going to be so excited you're going to pass out with excitement? Okay, any questions on what I did? Seems pretty easy, doesn't it? Doesn't it?
No.
But Mr. Trutna, this is trigonometry. That should be hard. It's not. It's just a big, scary word. Okay, so we kind of have that right there. All right, moving on to the next problem. Okay, Victoria, we're back to you. If we have time to do 3 examples, we'll do 3 examples. If we only have time to do 2 examples, we'll only do 2 examples here. Okay, all right, Victoria, you got to work your magic again. Here's my next example. I have a right triangle. Victoria, how much would you like the slope angle to be? 22 degrees. So let's put a 22 right there for the slope angle. Victoria, give me a variable. C. So we're going to make this bottom side of the triangle C. And Victoria, how long would you like the delta y side to be? 8. Okay, there we go. We're going to find the value of C. Okay, as Ethan said, you cannot use Pythagorean theorem to find C because in order to use Pythagorean theorem in a right triangle, you have to have values for 2 of the 3 sides. I only have values of 1 of the sides. So to solve this, I'm going to go to my graphic organizer. I'm going to find the triangle that had the slope angle of 22 degrees, which you can see is right here, which makes my delta y 2, my delta x 5, and I am going to write that triangle right next to my given triangle, orientating it the exact same manner that my given triangle is. Okay, so there we go. I have the 22 degree angle. I already forgot when I do this. What are the sides? What and what?
2 and 5.
2 for delta y?
Yep.
Okay, and 5 for delta x. Okay? So you guys, there we go. There's my 2 triangles. Okay? Couple questions. Are these 2 triangles similar?
Yes.
Yes. Why? The angle rule. You guys are amazing. Because the triangles are similar for angle, what does that mean about the fractions? So what do? I have to write the fractions and I have to cross multiply. Okay? C over what? What's 1 fraction? C over?
2.
C over?
5.
5. 1 fraction is C over 5. Okay? What's my other fraction? 8 over 2. Now, I'm just going to write 2 over 8, and I'm just going to stop. Don't write that. Can anybody tell me what's wrong with me writing c over 5 and then the next fraction writing it as 2 over 5?
They're like, it's like off.
Right, it's off. I flipped the fraction in the wrong manner. Okay? The c part, you guys, comes from the big triangle. So all the numerator values have to come from the big triangle. If I had a nickel for everybody who has done this right here where they flip that second fraction, I would not be teaching math right now. I would be sitting on a beach in Bermuda, retired and a millionaire. So what's the other fraction? 8 over 2. When triangles are similar, it means the fractions are equal. We cross multiply and then we solve the problem out to find the missing piece of the triangle. So I'm going to go c times 2, which is 2c. I'm going to go 5 multiplied with 8, which equals 40. The results when you cross multiply are equal, and now I would divide by 2. What's c equal to? 20. Okay, there we go. All right.